Okay, we are working through some of the packet review questions for the Q3 quarterfinal, which is coming up on Thursday of this week. It is currently Tuesday, so we have still tomorrow, Wednesday, during class to study, but tomorrow's mostly going to be a work on the Schoology quiz that's in the files. So I'm going to give you lots of time to work from about the middle of today on. You'll have work time. So I'm just going to hit a few prime topics, one of which is long run value. So we are looking at this problem right here. Everybody put that in your calculator, and I'll pause for a second while you do that. Okay, so I'm putting this in my calculator, and I hit this part. But Mr. Server, you've always said to put in 1 plus or 1 minus something. If I was going to do that for this 0.75, which is called the what? Common ratio. That's called the common ratio. I would put in a 1 minus 0.25. Why would I do that? Because then it shows me the what? The decay rate. Good. By doing 1 minus 0.25, it's smarter than just putting in a 0.75 because it shows me it's 25% decay, because they'll often ask you that question. Okay, then I'm put parentheses, and then I have to put plus 25, and then I'm going to delete off the rest of the numbers I had from my other problem. Okay, good. And then the starting value, UN min. How do I know it's the starting value? Well, N min is 0. It says it right up above. N min is 0. So U sub 0 is what it's asking for. U sub 0 was 48. So I'm going to put in a 48. Okay. So now if I look out on my chart, just save me some time. I'm going to go to table settings. What line does it start leveling off at about? 39, it says. I'm going to go to 37 just like it says. I'll hit table. Ought to be good enough. And it takes a little while to crunch these because it's like running through 37 calculations. And look at that. It leveled off. It's pretty much 100 from then on. So what's the long run value? 100. All right, now let me show you how you would have done that without a calculator, because that's also on the no calc part of the test. Do you get that this and this are a term and the term in front of it? In the long run, do you get that they're pretty much the same thing? A term and the term in front of it. They're pretty much the same number. That's why we put x's in for both of them and solve the equation. Now, could you do it with a calculator? Yeah, but if you were going to use a calculator, you might as well just typed it in like you just did. So imagine for a moment there's no calc allowed. How do I solve this equation? Hint, don't say subtract 25. There's variables on both sides. So, yes? Yep, subtract 0.75x. Now why? Because this needs to go away. Then we'll have only one set of x's equals a number. What is 1x? It's like $1 minus 75 cents x. 0.25x. And then I have 25. And I'm really close. So what I'm going to do next? Divide by 0.25. Divide by 0.25. And this one will bother some people. 25 divided by 0.25. I would encourage you to just say, okay, I'm not sure exactly what that means, but I'm going to think it through and go, well, divided by 0.25, that 0.25 is the same as 1/4. So I could say that this is 25 divided by 1/4. Do you agree that that's the same thing? And then, since there's no calculators, I got to figure out a way. Oh, wait, instead of dividing by 1/4, can't I do that flip and multiply deal? 25 times, flip it, 4 over 1. And that's just 100. And therefore, the answer's 100. And we already knew it was 100 because we did the calculator over here, and it said, and the answer was 100 in the long run. Okay, that's how to do it by hand. All right, so what's long run value? Now, there's a whole lot of topics that we can talk about, but I want to hit some of the high points that I know. Like before, you remember me working on questions like, what's the interest that you paid? Those are the hard ones from that one section. Okay, if you want to review those, you could go back and watch the video from yesterday. But I am going to today talk about some of the harder ones that you'd run into in the other sections. So what's left? Well, once you've done all of the loans and investments, you come to the exponentials. It's all about the fraction exponent. I don't want to do all your homework problems for you, so I'm going to do some that are similar. What if I have 1 over 27 to the negative 2/3 power? Do you get that's actually 3 things? The negative and the 2 and the 3? And you can do them in any order you want. But generally speaking, you should make the answer smaller before you make it bigger. So you should do the root somewhere near the beginning. You got 3 steps. Those 3 things. Try to figure it out. The answer is just a number. I'm not going to say the answer, but I want you to see if you can figure it out. Once you've got it, ask if the person next to you has it. And then if they've got it, compare answers. I'll pause for a second while you try that one. Okay, for those of you that were stuck, would you agree that this means flip? If I were making notes, I would write myself this note, because fraction exponents, it's all about these 3 things. A negative in front means flip. This means find the root that it says, the 3rd root. And this one is a normal power. So if I 3rd root it and flip it, what should I do first? How about I just flip it and it turn into 27? Okay, I'm flipping first. I did that, and it's now just 27. 27 over 1, but that's 27. And now the negative's gone, and now I just did one of my 3 steps. What would be smarter to do? Square it? Who wants to square 27? No thanks. So probably cube root, right? So what's the cube root of 27? 3. And then you square it. Raise your hand if you had 9 for your answer. Okay, good. That's fraction exponents at work. All right. Next topic. Is that a cell phone? Nah, leave it up on my desk. I just want it back, or you can have it back at the end of the hour. I need your full attention. This one will tell me whether or not you know how to write this weird notation into a fraction exponent. The answer is x to the something. See if you know. Do number 17 right now. I'll pause while you give that a shot. Okay. Did you say x to the fraction power where the roots go on the bottom? I got lots of little sayings like that. You might want to even write them down, because sometimes that's good to remind yourself right before the test. If the roots go on the bottom, the root here is the a. So that's where the roots go, on the bottom. And the b is not a root. That's a power, and that goes on the top. X to the b over a. Got that one? Okay, now a quick review of all the exponent rules. Like, for instance, did you know that you can do exponents? Sorry, my computer's behind here. I'll give pause for a second to let it catch up. I could, but I can't record that, which makes it tough. All right, so I got to give you a few practice on powers. Everybody try this little 5-question quiz. And if you know all the answers to these 5 questions, then you probably know the basics of powers. Let's see. Oh, and then there's one more that people usually mess up. See if you get caught on this. Number 5. See if you know your power rules. I'll pause while you give that 5 little question quiz a try. Again? All right, here we go. This one is x to the, say it if you know it. 10th is correct. You multiply on that kind. This one is x to the negative 3rd, but can I leave it that way? No, because you go 2 minus the 5 makes negative 3, but you can't leave it that way. I'm going to put it over 1 because you can do that with anything. Then I'm going to flip it and say this x to the negative third isn't happy where it is, so I'm putting it down here. And that'll be 1 over x to the third. Raise your hand if you had that one right. Awesome. Next one is numbers go with numbers and letters go with letters, or variables go with variables. That goes together and makes 10. This goes together and make x to the what? 7th. You add them when they're like that. They add the powers. Okay, then this next one, it's got a fraction. It's going to have a fraction answer. It's got a 2 over a 3. Can you reduce that? Nope. So it's just 2 over 3 still. Can I fix this x situation? Yeah. Let's put these together first. They make x to the what? But these guys weren't happy, so they come up and join them. Now it's x to the 9th. Now if you go 7 minus negative 2, that would have worked. Because that really means 7 plus 2, which makes x to the 9. Get what I'm saying? Do you get this as x to the 7? If that's x to the 7, I can go 7 minus negative 2. Because remember, when you subtract, you go this way, you subtract them. So this would be x to the 7 minus the 7 minus the negative 2 means 7 plus 2, which makes 9. So it even works that way. Either way, that's the final answer. Those are always tough for kids. Then we have the final question was number 5, and unfortunately, you can't actually do it. Did you think you could add those together? It was x to the 2nd and x to the 5th. They are like apples and oranges. They can't be added. They're not like terms. So the answer is just x to the 2nd plus x to the 5th. Done. Can't change it. Okay? So let me give you another one that's similar. X to the 2nd plus x to the 2nd. Now are they like terms? Now you can add them. So what is it? Good. 2x to the 2nd. Does it matter if there's parentheses around the 2x or not? Yes, it does matter. And there are no parentheses in that case. All right. I'm going to pause for a second while I get my smartboard fixed. Okay, tech issues over with. So now, exponentials have a lot of problems like this. X to the, let's make it a to the 3rd over a to the x is equal to a to the 2nd to the 3rd. That involves all kinds of like, do you know the right rule for this kind of thing? When you're done, if you do it right, you'll have a power, or sorry, you'll have the bases the same. You'll have a to the something equals a to the something. And then you'll just set these equal and it'll be easy from there. See if you can figure out how to write each side as a to a power. So one of the biggest things in exponentials was set your bases the same. Well, this one's pretty easy. It's a to the what? Hello, what's this one? A to the 6th. Over here, it's a to the what? 3 minus x. Do you get that you subtract in this kind? So we subtract 3 minus x. Now, why was it smart to do that? Because now this is the same as this. And that means this has to equal that. 3 minus x has to equal 6. How do I solve that? Get the x alone. What's up by the x? The 3. Take away 3 from both sides. Negative x equals 3. Am I done? Multiply by negative 1, x equals negative 3. How many of you had negative 3 as your answer? Most of you. Good. Okay. So that's a typical exponential kind of problem. Then we come to logs. Let me do a bunch of review of logs for you. There's a whole bunch of little rules. I'm telling you, you would be very wise to listen to these because I bet you almost every one of these is going to come up on the test. What is 5 to the log base 5 of 8? I'll give you a hint. The bases are the same. And if the bases are the same, the answer's already there. 8. How about this one? Let me think. log base 3 of 9. The bases aren't the same, but you could make them the same if you made that 9 into what? 3 to the second. Now the bases are the same, so what's the answer? 2. Okay, good. All right, next kind of thing is a rewrite. Log base 3x of 2 equals 1/2. Can you rewrite that? Because if you can't rewrite that, you won't be able to solve that on the test. How do you rewrite it? When I say rewrite, it means change it from a log into an exponential, or from an exponential into a log. What is this one already? A log. So we got to change it by making it exponential. So it's this, except sadly, you get this one wrong. That to the that equals that. What? That seems right to me. Parentheses around this. That forces me that my next step has to be square root on both sides. Just to clarify, if those parentheses weren't there, you'd be doing it wrong, and you'd be dividing by 3 next. That's why the answer would be wrong without those parentheses. This has imaginary parentheses around it. That's the thing I'm trying to say. Remember that. So, squaring both sides becomes 3x equals 2 squared is 4. Now I divide by 3, and if you were actually calculating like how much oxygen you will need on your next space flight on SpaceX, do you think they double check those calculations? Do you think just in case they throw in extra? Yeah, absolutely. Because it's not too expensive to add a little extra oxygen, and you don't have enough, all your passengers die. So what am I trying to say? I'm trying to say you should check to be sure, and you only have so many problems. It's worth checking. And these are what kind you can check. Let's see if it actually works. It says 4/3. I stick it here. Do you get that the 3 cancels the 3? Okay, and then this becomes log base 4 of 2 is 1/2. Could that be true? Log base 4 of 2 is 1/2. Well, then you'd go 4 to the 1/2 power is 2. Does that check out? Yeah, that works. Was there ever any point in this problem where I took the square root of both sides? No. Do you remember on those problems where all of a sudden you're doing 1/2 power and 1/2 power? If you do that to both sides of your equation, what do you get? Plus and minus. Let's say you get x equals plus and minus 8 are your answers. Do you just leave it automatically? Those are both right? No. You check them both. Let me show you. Let's say the original problem was like this. Log base x squared of 5 equals, I don't know, something over here. Do you get, in this case, both 8 and negative 8 are okay? How come you thought you said, Mr. Server, that negatives aren't okay in logs? When the negative goes in, it gets squared, and it's not negative anymore. See? All right, I'll give you another one where both of them would work. Or I'll just do it differently. You tell me which one of them would work if I said it was log base 1 minus x. Would it be x equals 8 that would work, or x equals negative 8 that would work? Negative 8. Yeah. Negative 8 is the one that works because you're putting in a negative, so it becomes 1 plus 8. So this one works. What's this one called then? Extraneous. How do I know that one doesn't work? Stick in an 8, and you get 1 minus 8 makes negative 7. Can you have a base of negative 7? No, you can't. That's why you cross it off and write EXT for extraneous. Okay, so that's one of the biggest things that comes up in logs. Next one for logs. E, how about this? ln of e to the 4th. What was my tip on ln's? Always replace them with log base e, because as soon as you do that, do you see how these are the same, and therefore the answer is 4. Everybody try that on this one. E to the ln 1.8. Actually write this, and actually do the thing that I said to do when you hit an ln. Mr. AK, what do you do when you hit an ln? Okay, and then what did you notice after that? And therefore, the answer is 1.8. Good. Sir? Could it ever be log base e to the 1/8 and then Wait, log base e to the of 1/8, you mean? Yeah,
Wait.
nothing wrong with that so far.
ln.
That's the same as log base e.
Yeah. But then have an e on top of the 1.
Like that?
No. Like.
Oh, you mean on the power on it?
Yeah.
All right, let's see what the answer to that would be. Okay, so first off, you go, ln gets changed to log base e, and I have 1/8 to the e. Now, let me ask you this. Are the bases the same? So this doesn't work. Now, if you said, you have to figure that out, Mr. Server. I could figure it out. I would just set it up this way. This can all go in the calculator. And it would be ln of 1.8 to the power of e. Because 1.8 to the power of e is just a decimal. Because the power of e just means to the power of 2.718. So I just use a calculator. It's the only way you get your answer on that one. Okay, there we go. All right, so we've covered log base e. I think we've covered pretty much everything that's like the really important stuff. There's a lot of little details. I wanted to give you some time. So this is the part where I stop. And your job for the rest of this hour is to finish the worksheet. I know I'm not finishing class, but between now and then at home tonight, finish the whole worksheet, all the questions. Just the worksheet, though. Then there is some Schoology quizzes in there. Those Schoology quizzes are what I'm assigning tomorrow. And we'll give a lot of time to work in class on them. They'll tell you if you're right or wrong. Here's really what's critical, though. You get done with the Schoology quiz and it tells you had 4 wrong. Do you just go, oh, that's not bad? No, those 4 that you had wrong are probably ones you're going to get wrong on the test tomorrow. So take the time, look at them, bring them up, ask me, why am I getting this wrong? Try to figure it out yourself. Like, you know what the answer is because they tell you, like, the answer should have been 8. And you, like, rework it until you get it to come out to 8. That's how you really study for this test. All right, that's all I got for you for today.